All right, welcome. You want to go over those questions on the quizzes. I'm going to go through and click on the asynchronous link. And my name is going to be I win, but not really. So go ahead and start the game. A couple others are playing, so that's awesome. Let me show you how to do these questions, shall I? So first question is absolute value v plus 8 minus 5 equals 2. Use x when you're putting it in Desmos. So we do absolute value of x plus 8. Close it up, minus 5. And then on the second line, do y equals 2. And move your graph over, see if you can find the solutions. And you have -1, -15. Question number 2, 3 absolute value x plus, or negative, 3 absolute value -8x plus 8 equals 80. 3 absolute value -8x, close it up, plus 8. And then you're going to do y equals 80. We're going to zoom out. And we're going to have 2 points of intersection again, -3 and +3. All right, third question. Solve the following equation. -2 absolute value, -2r, we'll call it x, minus 4, close it up, y equals -12. They're going to cross at -5 and -1, or +1. -5 and +1. All right, number 4. Absolute value, -2n, 2x, plus 10, y equals -50. Zoom out. These graphs don't touch each other, so there's not going to be a solution. Number 5, describe the transformation that is applied to the parent function, f of x equals absolute value of x minus 5. When you're subtracting on the outside of the absolute value, that's going to go down. I will show you the original function, absolute value of x. But then the parent function is absolute value of x. Close it up, minus 5. And you can see that this did move down 5 units. So it's going to shift down 5. Number 6, choose the correct parent translated function from the absolute value parent function. So this is going down. It's flipped, so it's going to have a negative out front. It's shifted up. So we should have the second option here. Let's test that out. And there's your answer. The negative is flipping it, and then the +2 on the outside is shifting it up 2. Write the equation for a graph that is vertically compressed by a factor of 2/5 and shifted up 6. So the compression or stretching is always going to be the number out at the front. So let me first do the absolute value of x so we can see what that looks like. If I wanted to compress, I need to multiply that first number, that first absolute value, by a number between 0 and 1. So that's a compression. So the 2/5 out front is vertically compressed. And then shifting it up 6 is going to require you to add 6 at the very end. So vertical compression, and then shifting up 6 plus 6 at the end, it's going to be the first option. Now I'm gonna make this a little bit wider here, just so you can see. Anytime that you add 6 in the parentheses, that's actually going to shift it left 6. So we don't want that. And this is going to shift it right 6. This is going to make it up 6. This is going to stretch it by 6 and shift it down 2/5. We don't want that. So it's going to be this one. All right, how does y equals absolute value of x move to form y equals 1/2 absolute value of x plus 3? Well, to me, it looks like it shifted up, but it also got wider, so that 1/2 is going to compress it. So it's wider and shifted up. Opens up, wider, shift up. Opens up, skinnier, shift down. Opens down, wider, shift up. Opens down, skinnier, shift up. So it's going to be the wider one. What are the transformations of the equation y equals negative 1/2 x plus 3 from the parent function absolute value of x? So negative 1/2 x plus 3. It's pretty much the same as last, but there's a negative. So it's going to reflect. So that negative is going to reflect it over the x-axis. It's still going to be wider because it's been compressed, and it's going to shift up 3. So we want to select all that apply. So it reflects. It's wider, and it also is shifted up. That's vertical. All right, the blue graph is the parent function. F of x equals absolute value of x. The red must be, looks like it shifted right 2. We can verify that the absolute value of x minus 2 in parentheses, or in the absolute value, is going to shift it right 2. So you can see that there. That's at 2. So minus 2 in the absolute value sign. Now we're into inequalities. We have 3 absolute value of 2x plus 7 minus 7 less than negative 4. You can type the entire inequality into Desmos. And anytime that you type the inequality and you're shaded between two numbers, the lowest number is going to be the one on the left side, and the highest numbers on the right side. So negative 4, x, all your values of x are between negative 4 and negative 3. So that's actually going to be this one here. And you can test that. If I did negative 4 less than x less than negative 3, that should be this one here. And looks like I have a typo. So if you got that wrong, my apologies, but that should be a negative 3, and it should be that one there. I forgot to fix that typo. Okay, number 12. At the Texas Design Company, the page 21 average starting salary for a new designer is $33,600, but the actual salary could differ from the average by as much as $1,560. Which inequality could be used to determine if a salary X falls within the range? So we want to use the number that's the ideal, the middle number, to be in the absolute value function. So this 33,600, that's the ideal salary, that's the average. That's going to be inside the X minus, that's going to be the number after the X minus. It's not going to, you don't want the actual salary to be any more than 1560. So it's not, 1560 is how much it could be off by, but it's going to be less than or equal to it. And I'll show you a visual of what's going on with that. So if you do the absolute value of X minus 33,600, and then you make that less than or equal to 1560. And of course, you're going to need to see the graph. So I'm going to zoom out of that. And there's going to be a little narrow range over here where the values can be between. So they can be as low as 32,040 and as high as 35,160. And you can get those numbers by doing 33,600 minus 1560. There's your 32,040. And you can do 33,600 plus 1560. And there's your 35,160. So you can see the low end and the high end there. So we know that this is going to be your correct inequality. Number 13. A candy manufacturer puts 240 pieces of candy into each bag. The bag can be off by 8 pieces. Write an absolute value inequality that displays the acceptable amount of candy pieces that it can be in a bag. This is just like the last one. So this is your ideal candy amount, but it can be off by as much as 8 pieces. It follows the same inequality. The 240 is going to be the number inside the absolute value, and then the 8 is going to be how much it's off by. So these numbers are a little bit easier to work with, but they're smaller, but it's going to be the same thing. This question is a little bit different, but it's going to follow the same type of formula. You are classified as having a normal body temperature if your temperature is above 98.2 degrees and below 99. Which inequality best represents the situation? On this problem, what you want to do is you want to get the middle number. So we want to average those two numbers together. So we will do 98.2 plus 99. And then we're going to divide that number by 2. And you should recognize 98.6. That's the average ideal body temperature. So that's going to be the number right in the absolute value. And the amount it can be off by, if we do 98.6, or if we do 99 minus 98.6, that's 0.4 degrees. And if we did 98.6 minus 0.4, you'll see that it gives you the low end, 98.2. So 98.2 to 99 is that range, and then 0.4 is how much it's off by, but your middle number is going to be 98.6. So it should be this one, t minus 98.6 in the absolute value, and we're off by 0.4. What is the equation of the graph below? Well, that's pretty straightforward, but I can kind of rule out, I know that it shifted left 4, so it's going to be x plus 4 in the absolute value, and it shifted up 2, and it's reflected. So if we factor all that in, reflecting is going to have a negative outside. Absolute value is going to be x plus 4, and then plus 2. And let me click on home so I can get back to what it should look like. And that should be the right answer. You can see the vertex at negative 4, 2, and it's going down. So negative absolute value of x plus 4 plus 2. And finally, one more. Which represents the solution set to the inequality. So 2 absolute value 2x minus 7 plus 5 greater than or equal to 23. Close this one up. So this is shaded in opposite directions. That means anything less than negative 1, including negative 1, so anything less than or equal to negative 1. And also anything greater than or equal to 8. So less than or equal to negative 1. You see how that overlapped it. And then x is greater than or equal to 8. That overlaps it. So less than or equal to negative 1, greater than or equal to 8. it would be this one. That should be a greater than or equal to sign. Again, typo on this one. I'll have it fixed next class. But less than or equal to -1, greater than or equal to 8. And put an or between because they're going in opposite directions. All right, I hope that was helpful for you. Thanks for watching.